Okay, circles 103, the practice problems. So here are some problems that we're going to see when we talk about the angles within circles made by different chords and segments and all that kind of stuff in a circle. So here's our first set of problems. We have this circle, and we're told that AC is 156 degrees. That really should say the measure of arc AC is 156 degrees. So this is 156 degrees over here, and we're told that segment AB is congruent to segment CB. Well, point C is right down here. Okay, so now here we have something that we got to talk about, and that reminds all the way back to Circles 101, where we're told that if two chords in a circle are congruent, then their arcs are congruent. If the arcs are congruent, that means they have the same length and the same measures. So that means from A to B and from B to C, those two arcs have to have the same measure. Well, what would that be? Well, I know the whole thing is 360, and if I subtract off 156, I get 204 left over. Well, now both AB and BC added together have to account for that 204. So each of these arcs is 102. Okay, so now we have all of our arcs marked off. That's good. That'll help us figure out the rest of this. Now, the rest of this is all angles. Now, here's the nice thing. 8, 7, and 9 all have M as the center point. Anytime you have M as a center point, and M happens to be the center of our circle, and if M's the vertex, that means you got a central angle. And as we figured out in our investigation, and as we figured out in the video, the measure of the central angle is the same as the arc. So when I look at number 7 here, angle AMC, measure of angle AMC, I got to look at the arc that's inside it. That's this one here. It's going to be 156 degrees. The measure of angle BMC, number 8, BMC is this one right here. That's going to be 102 degrees. Let's put a degree mark up there. The measure of angle BMA, right there, 102 degrees. Now, that leaves us with angle ABC. I have got to do some erasing here because I've got too much stuff on there. ABC. Okay, so we take a look at that. Note, B is right here on the circle. A and C are both points on the circle. So this is an inscribed angle. And according to our investigation and according to the video, an inscribed angle has the measure of half the arc. Well, the arc is from A to C here. So half of 156 is our answer. And a half of 156 is 78 degrees. So that's how we do those type of problems. Well, now let's move on. Let's take a look at a slightly different problem. In circle M, the measure of AC and the measure of CB are tangents to the circle at point A and B respectively. So ray AC and ray CB are tangents to the circle at A and B respectively. So if angle ACB is 58 degrees, ACB is 58, then what is the measure of angle AMB? Ooh, that's a good one. So if this angle is 58 degrees, what's this angle? Tough problem. A lot of different ways we can go about it. Here's the easy way to think about it. I know that MB and AB have to be right angles because the tangent and a radius are perpendicular to each other. And I know in this particular figure, all of those four angles would have to add up to 360 because it's a quadrilateral. So if I take 360 and I subtract 90 and I subtract 90 and I subtract 58, whatever's left over is my answer. Well, 360 minus 90 is 180. 180 minus 58 is 122 degrees. So that one, although it looked a lot more difficult than what we were expecting, turned out to be a real simple problem. Now, what if I know angle ACB is 71 degrees and I want to find the measure of arc ADB. I want to find this big arc over here. That's what we're trying to find. Little tougher problem here. I could go about it the same way. Go 90-degree angle, 90-degree angle. That'll work real well. Figure out this missing angle. So let's go ahead and do that. So 360 minus 90 minus 90 minus 71. And if we do that, we get 109 left over. Okay, so this angle here is 109, which means that this arc here is 109. So how long is the other arc? The other arc has to be 360 minus 109. So it's 251 degrees. So the measure of arc ADB is 251 degrees, and it's ADB, it's the major arc, so we needed the one that was more than 180. Okay, so that's how we do that type of a problem. Well, this isn't too bad so far. We haven't done any of the things that we've learned about. Okay, measure of arc AB. So which one is that? Minor arc, so it's this one here. This is 118 degrees. And we want to find out the measure of angle ACB. That's our angle out here. Ooh, how are we going to do that now? Well, we have a couple ways we can do that. 360 minus 118. Try that again. 360 minus 118 gives me 242. So our major arc here is 242. Now we're told anytime the angle is outside the circle, it's the half the big arc minus the small arc. At least that's what I told you in circles 103. So the measure of the angle is half the big arc minus the small arc when we're outside the circle. So I need half of 242 minus 118. Well, what's half of 242 minus 118? Well, what is 242 minus 118? Now if I subtract it off, I get 124. Half of 124 is 62 degrees. So that means angle ACB is 62 degrees. So that's how we do that type of a problem. Oh, now let's move on here. This looks a little bit more promising. We're told the measure of arc AD is the same as the measure of arc CE. So this arc is the same as that arc. And the measure of arc DE is 30. So this is 30 right here. And the measure of major arc AEC. AEC. Make sure we go the right way here. AEC. All the way around this way is 260. So how long is arc AC? Well, that should be pretty easy because the whole circle is 360. And if A to C going through E is 260, that only leaves 100 left. Fantastic. Now, what about angle AXD? We got a problem. X is not the center of the circle, and it does not lie on the circle, so it's one of those angles that is inside. So we've got to add two arcs together. Here's the problem is I don't know what the measure of either one of those arcs are. What I do know is that the measure of arc, let me undo that. Okay, I do know that the measure of arc AD plus the measure of arc DE plus the measure of arc CE all have to equal the 260. Because this arc, and this arc all make it up. I know this one is 30, and I know these two are the same. So I'm going to call them X. So X plus 30 plus X has to equal 260. So 2X plus 30 has to equal 260. So 2X must be 230. So X must be 115. Okay, let's take that information to our circle here. So this is 115. This is 100. This is 115. And this is 30. Okay, now we have all our arcs. Now to figure out AXD, that's this angle right here, According to the theorem we have, it says it's half the sum of the two arcs. 1/2 the sum of AXD's arc and its vertical angle's arc, so the one right on the opposite side. So AXD would be arc AD, so that's 115, plus the arc of the angle right on the opposite side, that would be the EXC angle. So that'd be, its also arc is 115. So half of 115 plus 115 is 115. Well, that one worked out pretty easy. Now what's the measure of angle ABC? I got to figure out where ABC is. Okay. Arc ABC is out there. Now that's a point outside the circle. So when it's outside, it's half of the big minus the small. Inside is half of arc 1 plus arc 2, where those are 2. So I need a big arc minus the small arc. So what's my big arc? My big arc is going to be the one that's inside. It's going to be the 100. So 100. The small arc is the DE, so it's the 30. And I need half of that. 100 minus 30 is 70. Half of 70 is 35. So angle ABC is a 35-degree angle. Wow, we're just zipping right through these now. Okay. So take that off of there. Bring back in my 30. I'm ready to look at the last problem. DXE. DXE is that angle right there. Now, I can do it two ways. I can see again that I have an angle on the inside, and I can use that as my way to figure it, which means I'm going to take half of arc 1 plus arc 2. So half of 30, which is the DXE angle, plus the AXC angle, that's the one that's on the opposite side, that arc is 100. So half of 130 is 65. That's one way I can do it. The other way to do it is realize DXE and AXD have to add up to be 180. And since I already knew AXD was 115, I knew DXE would have to be 65. Must have more problems down below. Oh, one more set it looks like here. Ooh, wow, look at this one. This is quite the barrage, I would say, that we have here. I've got the end circle M. Arc AB is 86. Arc CED is 25. I don't know why they use 3 letters there. AD is the exact same length as BC. And FG and FH are tangents. And HEG is 112. Let's put in some numbers. AB is 86. CED is 25. So this whole thing down here is 25. And we know that AD and BC are congruent. So that means their arcs from A to D and C to B have to be the same. So I can figure out this arc and this arc. Because 360 minus the 86 minus the 25, take that answer and divide it by 2 is going to have to give me those 2 arcs. So let me go to a calculator real quick and calculate that out. Oh, I'm guessing I'm finding it to be some viciously huge number. No, really. 360 minus 86 minus 25 gives me 249, and if I divide that by 2, I get 124.5. So from B to C, I get 124.5, and from A to D, I get 124.5. We're doing great now. Okay, what else do we need to know? FE and FG are tangents. Well, that's good to know. HEG is 25. Well, 112. So that means we can figure out this portion here and this portion here. So that's 112. So from H to G is 112. So HAG would have to be 360 minus 112, which would be 248. And if I subtract off the 86, I get 162. And if I divide that by 2, I get 81. So from B to G, it's 81. And from A to H, it's 81. Boy, this thing is just getting easier and easier as we go. We just start to figure out all these little angles and arcs. So from B to G, it's 81. From A to H, it's 81. From A to D, it's 124.5. So if I subtract that from 124.5, I get 43.5. So that means this inside here is 43.5. This one over here is 43.5. Wow, it's just looking super easy now, doesn't it? Let's see. And if I add up all those arc lengths, I get 360. Now, do we know that DE and EC are congruent? We're not told anything up here about that. It's possible. They could be. They could both be 12.5, but they may not be. It doesn't matter. Okay. We got all the arcs that we needed. I'm going to take out those 124s because they just distort things. AMB. What kind of angle is AMB? M is the vertex. The vertex is on the center of the circle. So AMB is a central angle. And as we know, central angles and arc measures are the same. So AMB must be 86 degrees. Fantastic. That's the super one. And now they want us to figure out what the measure of angle AEB is. E's over here on the right-hand side. And the arc that's inside AEB is arc AB. E is on the circle, so AEB is an inscribed angle. So this one was a central angle. This one is inscribed. And when it's inscribed, it's half the arc. The arc is 86. Half of 86 is 43 degrees. Wow, those two are both pretty easy. And now I have an AFB. AFB right here. Now, this is an angle outside the arc. Anytime the angle is outside the circle, it's half the larger minus the smaller. So 1/2 the large minus the small. Well, the large is our 86. The small is our 25. And if I take half of that, I get my answer. Well, 46 minus 25 is 61. And if I take half of 61, I get 30.5. Now it says find the measure of arc BC. Well, that's how we started this, is we figured out all the arcs to make sure we had it down. Arc BC was 124.5. And that was what we originally had, and then we figured it down from there on what everything was. Now, what type of angle is formed by tangent FH and FG? So this angle out here, what kind of angle is sitting here? That's what they want to know. All they want to know is it an acute angle? Is it an obtuse angle? Is it a right angle? What do we have? Well, if I take my circle and I figure it out, and we know the 81 plus the 86 plus 81 is our big arc, so 81 plus 86 plus 81, 248. Again, we're outside, so it's large minus big. So 248 minus the small was our HEG, which they said was 112. 248 minus 112 is 136 degrees. And we're supposed to take half of that, so a half of 136 is 68 degrees. So this is a 68 degree angle. So what kind of angle is formed there? It's an acute angle. Very rarely are you going to find that one to be a right angle or an obtuse angle unless things have to match up just right. So that is our circles 1 dash or 103 practice problems.